Hello friends, welcome to my lecture on binomial distribution. Binomial distribution is due to James Bernoulli. It is a discrete probability distribution. The Bernoulli process has the following properties. An experiment is repeated n number of times called n trials, where n is a fixed integer. The outcome of each trial is classified into two mutually exclusive categories arbitrarily called a success and a failure. Success and failure. The probability of success is denoted by P and it remains constant for all the trials. The outcomes are independent of the outcomes of the previous trials. Each trial in the Bernoulli process is known as a Bernoulli trial. Consider the random variable x equal to the number of successes in n Bernoulli trials, number of successes in n Bernoulli trials. Then x can assume the values 0, 1, 2 and so on up to n. When you consider n Bernoulli trials, okay, and x denotes the number of successes in n Bernoulli trials, then x can take value 0, 1, 2 and so on up to n, because there could be no successes. That in that case x will take the value 0, there could be all successes in all the n trials, so then n can take value n, then x can take value n. So, x will take the values 0, 1, 2 and so on up to n. To determine the corresponding probabilities, let us consider the event x equal to x, which means that in x of the n trials we have successes and in n minus x trials we have failures. Hence, we have the following arrangement of probabilities: P x times Q x n minus x times. Since the trials are independent, okay, so P into P that will be P to the power x, Q into Q to the will be Q to the power n minus x. The trials are independent, so we have multiplied the probabilities, okay. So, Q here is the probability of failure, that is 1 minus P, okay. Now, this is merely one arrangement, okay, this is merely one arrangement of having x successes in n trials. Total number of ways in which we can have x successes in n trials will be given by NC, total NCx, okay. So, probability that x equal to x equals NCx into P to the power x into Q to the power n minus x, where x takes values 0, 1, 2, 3 and so on up to n, okay. NCx here is the number of ways in which we can obtain x successes from n Bernoulli trials. So, probability that x equal to x is equal to f x is equal to NCx P to the power x Q to the power n minus x, and x takes values 0, 1, 2 and so on up to n. F x takes the value 0 otherwise. The distribution determined by the probability function 2 is called the binomial distribution, or we also call it Bernoulli distribution. Now, we can note that n plus 1 terms of the binomial expansion q plus p to the power n, okay, q plus p to the power n will gives us nc0 q to the power n, nc1 p q to the power n minus 1, nc2 p square q to the power n minus 2 and so on ncn p to the power n, which can be written as sigma x equal to 0 to n ncx p to the power x q to the power n minus x, okay. So, ncx p to the power x q to the power n minus x is x plus 1th term in the expansion of q plus p to the power n, and since p plus q is equal to 1, okay. So, sum of the probabilities, okay, sum of the probabilities is equal to 1, okay, and so f x is the probability function, okay. Sum of the f x is greater than or equal to 0 for all values of x, and sum of the probabilities of f x is equal to 1. Now, the binomial distribution is characterized by the parameter p, okay, and the number of trials. If we know the parameter p and the number of trials n, we can determine the binomial distribution. Now, let us show that the mean of the binomial distribution is mu equal to np and the variance sigma square is equal to npq. So, let us first show that mean of the binomial distribution mu is equal to np, okay. Ex is equal to mu, this is sigma x equal to 0 to n, okay, x into p x equal to x. Okay. So, this is sigma x equal to 0 to n x times n c x p to the power x q to the power n minus x. Okay. We may write it as sigma x equal to, because first term is 0. So, I can write it as x equal to 1 to n. Okay. When x equal to 0, this first term becomes 0. So, x times, then n c x can be written as n factorial over x factorial n minus x factorial p to the power x q to the power n minus x. Okay. Now, this x, when we cancel with x factorial, it becomes x minus 1 factorial. So, sigma x equal to 1 to n n factorial, we can cancel this x here and we get x minus 1 factorial then, okay, n minus x factorial, and then p to the power x q to the power n minus x. Now, what we do is we take one n from here from n factorial and one p from p to the power x. So, we can write it as n into p, and what is left is sigma x equal to 1 to n n minus 1 factorial over x minus 1 factorial n minus x factorial. Okay. So, this will be p to the power x minus 1 q to the power n minus x. Now, let us replace x minus 1 by j. Okay. So, we write this as sigma np sigma j equal to 0 to n minus 1, okay, n minus 1 factorial over j factorial, and here we have x equal to j plus 1. So, n minus 1 minus j factorial, and here we will have p to the power j q to the power n minus 1 minus j, okay, which is n p. This is sigma j equal to 0 to n minus 1 n minus 1 c j, okay, p to the power j q to the power n minus 1 minus j, which is equal to n p into q plus p raised to the power n minus 1. Okay. Q plus p is equal to 1. So, it is 1 to the power n minus 1. So, n p. Okay. So, now, so this is how we show E x equal to n p. Now, let us show variance of x, sigma square equal to n p q. So, for this we will calculate E x square. Okay. So, E x square is in a similar manner sigma x equal to 1 to n x square p x equal to x, and what we get is sigma x equal to 1 to n x square n c x p to the power x q to the power n minus x. So, this is x equal to 0 to n, x equal to 0 to n. Okay. Now, this is sigma x equal to 0 to n x square n factorial over x factorial, and then we have n minus x factorial, okay, p to the power x q to the power n minus x. What we will do is we shall write we write x square as x into x minus 1 plus x. Okay. If we do that, then we shall have, then we have x is E x square equal to, let us break it into two parts, sigma x equal to 0 to n, one part for x into x minus 1, one part for x. Okay. So, x into x minus 1, okay, n factorial x factorial n minus x factorial, okay, p to the power x q to the power n minus x. This the other part is sigma x equal to 0 to n x n factor ncx, okay, ncx p to the power x q to the power n minus x. Here also it is q to the power n minus x. Okay. Now, this part, okay, sigma x equal to 0 to n, okay, x ncx p to the power x q to the power n minus 1 is same as this. Okay. So, this second term on the right side, second sum is just e to the power ex, okay. Ex we have already calculated np. So, this the value of this we know, okay. So, just I have to calculate this first sum on the right side, okay. So, let us calculate this one. So, we have sigma x equal to 0 to n, okay, x into x minus 1 n factorial x factorial n minus x factorial p to the power x q to the power n minus x. Okay. Now, at x equal to 0 this sum is 0, at x equal to 1 also this sum is 0. So, I can write it as sigma x equal to 1 to n, okay, x equal to 2 to n. Okay. Then we have x into x minus 1 we can cancel with x factorial, and x factorial will become x minus 2 factorial. So, we get n factorial over x minus 2 factorial and then n minus x factorial p to the power x q to the power n minus x. Okay. So, now x minus 2 let us put at j. So, we get summation j is equal to 0 to n minus 2, n into n minus 1 we write outside the n factorial, then we have n minus 2 factorial, okay, and then here we have j factorial. Okay. This becomes n minus 2 minus x factorial, replacing n minus 2 minus j factorial. Okay. And here we get x is equal to j plus 2. So, j plus 2 q to the power n minus 2 minus j. Okay. So, I can write it as n into n minus 1 p square, and what is left is then sigma j is equal to 0 to n minus 2 n minus 2 c j p to the power j q to the power n minus 2 minus j, and this is equal to n into n minus 1 p square q plus p raised to the power n minus 2, q plus p equal to 1. Okay. So, this is n into n minus 1 p square. Okay. So, this is n into n minus 1 p square and this is n p. Okay. So, we have calculated E x square. So, thus E x square is equal to n into n minus 1 p square plus n p, okay, and hence variance of x is equal to E x square minus E x whole square is equal to n into n minus 1 p square plus n p minus n p whole square. So, we get n square p square minus n p square plus n p minus n square p square. Okay. So, this n square p square gets cancelled and we get n p times 1 minus p, which is n p q. So, this is how we calculate the variance of the binomial distribution. Okay. So, mean and variance are found like this. Now, let us go to some examples on binomial distribution. Let p equal to 1% be the probability that a certain type of light bulb will fail in a 24 hours test. Okay. So, let us say let x denote the number of bulbs which fail in 24 hours. Hours test. Okay. Then find the probability that a sign and p is equal to 1%, that is 0.01. Now, find the probability that a sign consisting of 10 such valves will run 24 hours with no valve failures. That means, we want the probability that x is equal to 0. Okay? There should not be any failure of valves. Okay? Now, P is the probability of that the certain type of valve will fail in 24 hours. So, this is equal to, so this gives you by binomial distribution probability that x equal to x. We know probability that x equal to x is NCx p to the power x q to the power n minus x. Okay? So, probability that x is equal to 0, no valve failures. So, NCx, n is equal to 10. Okay? So, 10C 0, okay, p to the power 0, q to the power 10 minus 0. Okay? So, we get q to the power 10. Okay? X denotes the number of valves which fail in 24 hours. We do not want any valve to fail out of the 10 such valves. Okay? So, we get q to the power 10, which is 0.99 to the power 10, because q is equal to, as q equal to 1 minus p. Okay? So, this 0.99 to the power 10 gives you 90.4% probability. Now, let us go to second question. The probability that a candidate satisfying the minimum requirement for a post will get it is 0.65. So, the probability of the candidate to get the post is 0.65. Okay. What is the probability that out of 10 candidates which satisfy the minimum requirements, at least 7 will get selected. So, let x denote the number of candidates who get selected. Then we want the probability that x is greater than or equal to 7. Okay. So, this is nothing but, let us write probability that x is equal to 7 plus probability that x equal to 8 plus probability that x equal to 9, okay, plus probability that x equal to 10. Okay. So, probability that x is greater than or equal to 7, at least 7 candidates will get selected, means we want the probability of having 7 candidates selected candidates, 8 candidates selected, 9 candidates selected and 10 candidates selected. So, this means that we have this by binomial distribution 10C7, okay, p to the power 7, q to the power 3, and here we get 10C8, p to the power 8, q to the power 2, and here we have 10C9, p to the power 9, q to the power 1, and then here we have 10C10, p to the power 10, q to the power 0. Okay. So, this is p is given to be 0.65. Okay. So, here q is equal to 1 minus p. So, this comes out to be 0.35. Okay. Now, we know the value of p. Okay. P is 0.65. We know the value of q. Q is 0.35. The binomial coefficients 10C7, 10C8, 10C9, 10C10 can be calculated. This is nothing but we can also write it as 10C3. NCR is NC n minus r. Okay. So, P7 q to the power 3 and 10C8 is 10C2. Okay. So, 10C2 P8 q square, 10C9 is 10C1. Okay. P to the power 9 q, and then 10C10 is 1, and so we get p to the power 10 there. So, we can put the values of p and q and binomial coefficients and then calculate this value. It comes out to be 0.514. Now, if the probability of hitting a target is 10%, okay. So, probability of hitting let us denote by p. it is 10 by 100. So, that means 0.1. Okay, P is equal to 0.1. Now, 10 shots are fired independently. What is the probability that the target will be hit at least once? Okay. So, target will be hit at least once. Let us say let x denote the number of times the target is hit. Okay. Let x denote the number of times the target hits, then the required probability is equal to 1 minus p x equal to 0. X equal to 0 means the target is not hit in any time out of n shots. Okay. So, we subtract from 1. So, that 1 minus p x equal to 0 will give the probability that the target is hit at least once. Okay. So, 1 minus p x equal to 0 means n is equal to 10. So, 10 c 0 p to the power 0 q to the power 10. Okay. So, this will be 1 minus q to the power 10. That means 1 minus q is 0.99. Okay. So, no, q is 0.9. Okay. So, 1 minus 0.9 to the power 10. Okay. So, 1 minus 0.9 to the power 10 will come out to be 0.6513. Okay. Now, let us see problem number 4. A certain device is shipped in lots of 50. Okay. Before such a shipment is inspected, 5 of these devices are chosen and tested. The lot is accepted if none of these tested devices are defective, otherwise the entire shipment is inspected. Suppose that the lot contains 3 defective devices. What is the probability that 100% inspection is required? So, probability of a defective device, let us find first. This is equal to 3 by 50, because the lot of 50 contains 3 defective devices. So, probability of a defective device is 3 by 50, probability of a non-defective device is therefore. So, probability of, so let us say this is P. Okay. So, probability of a non-defective device Q is equal to 47 minus 47 by 50. Probability of a non-defective device Q is equal to 47 by 50. Okay. Now, we are saying that the lot is accepted if none of these tested devices are defective. So, we have picked up a sample of 5 devices. Okay. If none of these 5 devices are defective, then the lot will be inspected. We want the probability that 100% inspection is required. 100% inspection will be required if out of these 5 devices, if at least one device is defective. Okay. So, the required probability that 100% inspection is required it means that at least one defective device is there, at least one device is defective in the lot of, in the sample of 5, in the sample of 5 devices. Okay. So, this is nothing but 1 minus probability that all devices are not defective. Okay. So, probability that x is equal to 0 if x gives the number of defective devices. Okay. Let x denote the number of defective devices in the sample. Okay. So, if we take x equal to 0, it will mean that there is no defective device in the sample. Okay. So, probability that there is no defective device in the sample, if we subtract that from 1, then it will give us the probability that at least one defective device is there. So, 1 minus x equal to 0, all devices are non-defective. So, 47 by 50 raised to the power 5. Okay. Because probability, because by binomial distribution, probability that x equal to 0 is 5c0, okay, p to the power 0, q to the power 5 minus 0. So, q to the power 5. Okay. So, 1 minus 47 by 50 to the power 5, this comes out to be 0.266. Okay. So, if at least one device is defective in this lot of 5, in the sample of 5, then the 100% inspection will be required. So, that is the required probability 0.266. That is all in this lecture. Thank you very much for your attention.